In example 4, it says graph the function f of x, which is equal to the sine of 50x in an appropriate viewing rectangle. So let's go ahead and do that. I'm going to put in the y equals button on our TI-83 calculator. We're going to put in the sine of 50x. And let's go ahead and choose a window here. We'll put in negative 12 for the minimum, 12 for the max. And since it's sine, we're going to go, the y minimum, y max should be just a little bit above 1. So it'll be negative 1.5 and positive 1.5. So let's see what that graph looks like. Okay, so here is the graph with that particular window. So we can see what this function looks like. But let's go ahead and change this up a little bit. Let's change this minimum to be negative 10 and then positive 10. Okay, so on the calculator you can see that just with those small little adjustment for the x minimum, x maximum, you can see now it's a lot closer together than what we saw in the first graph. Now let's try changing that to, let's say, negative 9 and positive 9, because we're going to keep, again, the y minimum and y max to be negative 1.5 and 1.5. Let's go ahead and graph. Okay, so again, now it's taking a different shape. So you can see here that just with those different types of changes, you're seeing a different look of the graph. Let's try another window. Let's change the minimum to be negative 6 and positive 6. So again, now we're getting more of a zoomed in picture there for that one. So you can see that each calculator is going to represent this differently. Desmos may not look the same with all 4 of these graphs that we've done on TI-83. Let's just check that out here real quick. Well, there it is. So if we put in the sine of, let's say, 50x, right? And there is your picture for that. And we're using negative 12, 12, negative 1.5, and 1.5. You know, let's go to negative 6 and positive 6 on that last one that we've done. So again, it looks quite different on each particular graphing device in this particular scenario. So let's take a look at these graphs here. So here is the look of what we got on our calculator. This was when we had negative 12 and positive 12. This is what we got when we had 1.5, negative 1.5, negative 10, and 10, similar to that. This was when we had negative 9 and 9, and then this was negative 6. Now again, this is on a different graphing device because they're all giving you different types of graphs. Now, in order to explain the big differences in appearance of these graphs and to find an appropriate viewing rectangle, we need to find the period of the function y equals the sine of 50x. We know that the function y equals the sine of x has a period of 2 pi, and the graph of y equals the sine of 50x is shrunk horizontally by a factor of 50. So the period of y equals the sine of 50x is 2 pi over 50, which is equal to pi over 25, which is approximately 0.126. Now, what this suggests is that we should deal only with small values of x in order to show just a few oscillations of the graph. And if we choose the viewing rectangle, negative 0.25 and 0.25 by negative 1.5, 1.5, then we're going to get this graph. So let's go ahead and change our window here to be negative 0.25 and then 0.25, and then let's graph. And so therefore, that's the graph that we're looking for. So again, just as we've seen in our other examples, we need to find a domain and range. But now when we're dealing with a trigonometric function, we need to take into consideration of the period so that we're able to look at the graph the way we would like to according to that particular function. And then we can see below here that this is figure 7. This is, again, using our x minimum and x max to be negative 0.25 and 0.25, and remaining negative 1.5 and 1.5 for the y min and y maximum.